Hey guys, welcome to Autodesk Inventor in less than 10 minutes. Today we'll be looking at something quite interesting, and that is how to create a mechanical plate inside of Autodesk Inventor 2022 Professional. Yes, that is the one that we have today. And what we'll do here is click on the new button. You'll see that we've got a part file over here, which is our standard IPT. And if we just click on the create button, that's going to allow us to create a brand new part. And we will let it cook. And once it's done cooking, you'll see over here, we've got a whole bunch of different buttons. Now, just like reading, you start from the left-hand side of the screen and you work your way to the right. At the very top of the screen here, we've got a new button, open, save, undo, redo, and so on. Just for those of you who have just started with Inventor, I do recommend going over to File at the very top here, that orange button, then down to Options. And inside of the Options area, we are looking to go over to the tab called File. And inside File, go to Configure Default Template. And in there, just make sure that this is set to millimeters and ISO. And once you say OK to that, it's going to ask you if you'd like to overwrite the file. Just say, yes, I would like to overwrite the file. And the reason you're going to do that is so that every single time we begin a brand new file inside of Inventor, it is in beautiful millimeters using the natural way of measuring things. I don't know who decided to use inches, but that is really, really heartbreaking. So what we're going to look at over here is we're going to click on the Start 2D Sketch button. I don't know why I started there, but it is okay. You'll see that over here we've got the XY, YZ, and XZ planes. Now, in this case here, we're going to pick the XZ plane because that's going to be showing us the top view. And you can see here, we've got X-axis and the Z-axis. Some programs show top as the Z, and that's usually, well, up and down as the Z axis, but Inventor uses Y as up and down. So as I zoomed in and zoomed out of this object, which you can't really see much because we don't have any shapes on our screen. So let's start by creating shapes on our screen. Here, we'll start the rectangle tool. I'll click over here in a blank space and I'll move my cursor. Remember, do not click and drag, do one single clicks or just single clicks. The reason you want to do single clicks is sometimes a click and drag can be a different function, and it also just makes sure that Inventor just works predictably every single time. So here we'll just use the vertical constraint on the middle point over here to the middle point over here. That yellow dot is the origin, which is the origin of the entire file. And you have to ground everything to a single origin point because that is where everything started. Think of it like the Big Bang. But in this case over here, we'll click there. We'll go dimension, create a new part there, or a new dimension there at the very top. And in this case here, when I placed that dimension, I was quite quick there. I said dimension, clicked on the top line, and then I placed the dimension down. Again, it's just two separate clicks. And then here we're just going to type in, let's call it width actually. So width is equal to 100, enter. And that's going to give us a width that is equal to 100. Then over here, we'll go height is equal to, let's go 200, enter. There we go. Now, if I double click on this value, you'll see that width has now become the heading over here. And this value here is now called height. And the reason it's called width and height instead of the D1 and D2 and D3, D4, D5, starting from D0 actually, those are all your dimensions. And every time you create a brand new dimension inside of Inventor, like if I start the circle tool up here and make a circle and just place down the object without any dimensions, should have just given us, you'll see here at the very top, it just says D3, for example. So if I just said hole is equal to 50, enter, then it makes a hole that has got a diameter 50. Finish sketch, and then I can just press E on the keyboard, and E is for extrude. And extruding is just taking a 2D shape, which is just this flat shape over here with no dimensionality, and making it 3D by clicking over there. Beautiful. Now we've got a 10mm thick plate, and we can just set the material over here to something quite nice like stainless steel. And the cool thing about using materials inside of Inventor is they allow you to specify the material. And once you specify the material, you can get stuff like physical properties, such as what is the weight of the file. So that if you're trying to import these things as parts from China, let's say, then at least you know that all 100,000 of these parts are going to weigh exactly X amount. Well, maybe not exactly because of packaging and stuff like that, but at least you got a decent, more or less value before you go and commit thousands, if not millions of rands to something. But in this case over here, what's really, really cool is the fact that we can go over to this area here called stress analysis. And in the stress analysis tab over here, we can actually create a brand new study. And in this case here, we've got a couple of different studies. We've got a static analysis, which will just run a static analysis on our particular part. So let's say, for example, we decided to run a simulation of this part here to see how much weight can it handle before it actually breaks. Then we also got a modal analysis, and a modal analysis basically goes through and analyzes the natural frequencies that occur within this particular part. So in this case here, let's say you've got a motor attached to this. You don't want the resonant frequency of this part matching up with the motor, because eventually it's going to create a lot of vibrations throughout the entire machine. Because in this case here, every time the motor swings in one direction, all the atoms in this part also swing in that direction. And that's not very good, because eventually that whole thing is going to break apart. We've got a shape generator over here, which basically just goes through and analyzes the overall structure of your material. And then wherever there's no stresses really running through a particular part, that just has that opportunity to weight reduce by getting rid of areas that don't really require or give any support to your part, thus making it lighter, which is really awesome. So it kind of looks like bones at the end of the day, which is basically what nature's been doing for 4 billion years. But anyways, debate for another time. We'll go over to static analysis. We'll say okay to this. And I should have talked about the bonded constraints, or contacts, but we'll probably get into that a bit later. We'll just go fixed over here. We just need to fix this into some particular location in space. You do have something called a parametric table, and a parametric table basically goes through and it allows you to adjust specific parameters, such as the thickness of the metal, to see if you have specific loads. Like, let's say I put a 10 kilogram weight. Do I really have to make this the plate 10 mil thick? Maybe I can get away with 2 mil or 1 mil. Just depends on the particular item that you have. But it's just a great way of actually just analyzing that and seeing that. So in this case over here, I'm pretty much happy with everything that's happening. I'm just going to turn on gravity, and gravity is ideally shown as Newton's apple, which is quite nice. And in this case, we'll just flip this going down, so that in this case here, we've got 9.8 meters per second squared, pointing downward. And that's going to be our acceleration of gravity. Absolutely lovely. So if I just hit simulate over here and I just say run, you'll see it's going to start cooking the simulation. And once the simulation is done cooking, we're going to see the von Mises stress, which is just a three-dimensional stress occurring throughout the part. And in this case here, it's sitting at 0.76 megapascals. We can also go through and add some probes to this if we wanted to see and inspect specific areas. Or in this case over here, we can just add our maximum and minimum probes, which are quite nice, because in this case over here, if I could just get rid of this guy here, come on, where is the delete all probes? There we go. Let us add in our min-max probes. So it's this guy and this guy. And obviously the minimum, oh, there it is. So it's actually the least stress is sitting on the furthest position from this particular part. What does that sound? Very weird. But anyways, in this case over here, you'll see there's also displacement, and displacement is basically how much is this part displacing just by gravity alone. And in this case here, we can see it's actually sitting at 0.009 millimeters, which if you actually look at this part, you might say, oh, but that's kind of BS, bro. But in this case here, it actually is true, because if I set this to actual, you'll see that the distance there is actually extremely tiny in comparison to this 10 millimeter part. So under its own gravity, it's pretty fine. Unlike some people's egos. But other than that, we'll have a look at just jumping over to finish analysis. Actually, let's just jump over to that exaggerated view before we leave, and we'll just go over to animate, and we'll just hit play here, and you'll see with the animate option that just allows you to animate through your entire video there, which is really cool. So you can actually just see how the stresses act upon that part. You can generate entire reports automatically. Really, really awesome stuff. And finally, that is basically it. So if I just go over to this little FX area, you'll see that we have the ability to go through and drive our height. And if I right click and say multi-value, I got 30 seconds left to show you something else. So I can just go 100, enter, 200, enter, 300, enter, 400, enter, 500, enter, say add. Okay, right click over here, multi-value, 300, enter, got 10 seconds, 500, add, say okay. And in this case here, pick on the list, boom, boom, done and dusted. The part updates automatically. Thank you for watching.